Okay, so let's dig into some details here. Let's talk about sector data. A sector data, what's in the sector data? There is data itself, but what is the metadata about that particular sector? Well, it's going to be an ID to actually find that sector on that particular drive, any kind of synchronization fields you need, error correction codes, ECC, some potential gaps, and then here's the interesting thing. It's 512 data bytes, but in order to actually physically lay that out on the disk, it's going to have that metadata, and that's going to take up 577 bytes of physical disk space. So those sector data are there. Bad sectors happen. Little tiny microscopic pieces of the disk go bad. If you have too many of those sectors go bad, the operating system will fail to pick up the information, and you'll have to rewrite the operating system to other sectors. If it's just data that's sitting in that area, the data will become corrupt. The operating system will mark that particular sector as bad and then skip over it at all cost. The reason why this happens is because hard drives wear out. Now, if you look at the hard drives that are out there today, they talk about this calculation of the mean time between failure, and they look at the total number of hours of operation of the particular drive. Also, that mean time between failure is actually the number of hours is being extended at this point because the operating systems are smart enough that in some cases they'll actually spin down the hard drive and not supply as much power to it when nothing's really going on, only keeping the operating system running in the RAM portion and not doing a lot of disk hits at that moment in time. So the drives actually last a lot longer than, say, 10,000 continuous hours between failures. But the other thing is that those calculations for the mean time between failures is not as accurate as we first thought. Google did a study about 5 or 6 years ago on these failures, and the drive manufacturers claim somewhere between 0.5% and 1% mean time between failure, and Google says it's anywhere from, on average, 2 to 6, but as much as 30% failure. Usually, by the way, that failure occurs in the first 3 months, having an early death, or it actually lives out its regular normal life and actually meets the manufacturer's specifications. So common causes of failures are just basically worn out voltages, viruses. The viruses that they're talking about there, the one in particular is called smoke on the water. It's very unlikely that that will actually work anymore for most operating systems to actually crash the write head into the platter itself. Bad sectors. If data is the sector that becomes bad, it might not be recoverable, so data is lost all the time. If the operating system fails in that case, it may have a redundancy built into it that will allow it to continue, but eventually it will rewrite that sector and rewrite that portion of the operating system, thus fragmenting the data so that it's not in one contiguous stream. Bad sectors can be created, or sectors can be marked as bad through malware and actually operator error, or operator users actually trying to make sure that they can hide these sectors. They mark them as bad and store data in there anyway, and then what they'll do is they'll tell the operating system, hey, I know that's a bad sector, but I want you to read from it anyway. Give me the data that's actually there, and it will actually oblige. When we do an image of a disk drive, we take all of the sectors, including the bad sectors, because it may be that malware or our adversary has marked those sectors bad, and we can actually retrieve data from that location. Cluster organization. So cluster entries are maintained by the computer's file system itself, and clusters are chained to each other through the algorithms of the operating system, knowing where the contiguous data is. It's ordered on the disk, and it usually uses continuous numbers, not contiguous numbers. Entire file does not have to be in one contiguous block, and in fact, with the larger files today, it's actually broken up quite often. Now, the cluster size is determined when the volume is actually partitioned. Larger volumes use larger cluster sizes. You can do 4 sectors all the way up to 64 sectors. A sector is going to have a certain number of contiguous bytes. 64 sectors obviously will give you a lot larger byte. Today what's happening is we're actually boosting up the number of sectors in a particular cluster because we actually have larger files being put on the drive. There is a slack space, and this is an area of the disk cluster between the end of the file and the end of the cluster. So if I said to you that I have a bus and we're going to go ahead and put the team on the bus, do we change the size of the bus to meet the team, or do we just say, okay, well, this bus can hold 60 people and it happens to be that your team is 45 people? What do we do with the extra area in that bus? Well, nothing. Or somebody takes up 2 seats, right? Slack space are those extra seats. And there is a greater number of files stored on the disk with larger cluster sizes, but also if we do a larger cluster size, we'll have a larger slack space. So a lot of this disk space is actually wasted because we can't write the file across different clusters. There are lost clusters, and this is not like bad sectors. This is a little different. Well, in a file allocation table file system error, what happens is it results in how the FAT system allocates spaces and chains the files together. It's a logical structure error that happens quite often, and it usually occurs because of interrupted file activities, inappropriate reboots at the wrong time. Now, we've taken care of the physical at this point, and next what we're going to do is we're going to leave this physical world behind and actually go into the logical world.